Hey everybody, my name is James and this is a Cardano starter kit. Today we're gonna tinker. I'm really excited. I'm calling this one Metadata, Minting, and Messing with Unsigs. If you haven't heard of them, Unsigs are a pretty compelling NFT project on Cardano. And as I'll show you today, they kind of push us to tinker. So this starter kit is for you if you're brand new to development and just want to know what it feels like to tinker and write code. There's a language called Python. Maybe you've heard of it. It's a really good place to start. I think a lot of people might agree. It might be the best language for beginners. I'm also certain that there's people who would debate that. But hey, everybody needs a place to start. If you're looking for one, Python's a reasonable one. If you're a developer who already knows code, but you're trying to understand more about how Cardano fits together, this starter kit is for you. I think this is going to help you get some insights into how to build and what might go where. If you're not a developer, first of all, don't say that. Anybody can write code. Anybody can learn this stuff. It just takes a little effort. But you know, wherever you are on your development journey, if you want to understand more about what's happening when an NFT is minted, this is for you. And if you're already a fan of Unsigs and you'd like to tinker around a bit, this is definitely for you. And I encourage you to ride that energy into really trying to do something new. I really hope that this starter kit provides that for you. Now, one thing I'm not going to cover today, and I noted that here, if you're looking for a comprehensive explainer simply on how to mint NFTs, I'm not really providing that today. I think if you do follow along with this starter kit, you will learn a lot about minting NFTs. And at the end, I'm going to show you a shortcut using a tool that a friend of mine made. But the thing we're not going to touch is image storage. Storage in general in decentralized applications is messy. It's a big problem. A lot of people are working on solving it. We are at Gimbal Labs working pretty hard on it right now, digging deep into what it really means to store information or media in a distributed or decentralized application. And frankly, I don't think the Cardano NFT space is really addressing this problem yet. We'll talk more about that, right? But if we really want to talk about non-fungible forever tokens, we still have a little work to do on the media storage piece. Funnily enough, this is part of why I find Unsigs compelling. So the first thing we're going to do today is we're going to look at what an Unsig actually is and where you can find it. And then in part two, we're actually going to play with some Python code, all of which is stored on chain. And then I'm going to make a few bizarro Unsigs and show you some options for how you might mint them. All right, so that's what we're going to do. Before we jump into that, let's pop into the command line for a second. So I recommend watching starter kit number 7 if you haven't. It gives you some background on how transactions work. And if you are familiar with that, I'm picking up right where I left off there. So I have this same address. And last time I made a starter kit about transactions just a couple days ago, query tip of mainnet, it was the Merry era. But just in case you haven't heard, I hope you have, we transitioned over the weekend at the start of Epic 290 into the Alonzo era. So there we are, okay? And something else cool happened. Again, this is going to make more sense to you if you did check out starter kit number 7 or if you've seen this before. But if I query the UTXOs in this mainnet wallet, or I'm using the word wallet lazily here, but at the address that is stored here as sender, it looks very similar to how it looked at the end of last week, except there, check it out, there's this new thing here. TX out datum hash, none. I wonder what that's all about. We're actually going to cover that a bit in starter kit number 9. So my goal today is to focus on things that were already possible before the Alonzo era. Talking about metadata, talking about minting, and kind of separate from that, encouraging you to go learn some Python. Okay. But I just wanted to celebrate this with you. Today is Tuesday, September 14th, and it's now the Alonzo era. Okay, so let's go back into this. This is a public repository. You can go access everything here on GitLab, okay? What I want to do is think about where an unsig is stored. So on pool.pm, maybe there's some unsigs, and I can open one up. And here's an image. And actually, if I click on that image, it brings me back to the unsig site. That's a kind of nice detail. Okay. And if I want to download the 4K image, it says it's stored on Amazon AWS. I mean, so if we only think about this image, this is convenient, but not decentralized. Now, decentralized is not an end in itself. We have to think about what that means, right? In the long term, what it means to me is that I don't have to rely on one company like Amazon to perpetuate data forever. Is it convenient? Heck yeah, it is. Amazon runs really powerful servers, and they're really helpful for what they do. And as such, you know what? I should celebrate that. But this is just an expression, right? This is just an image that represents something deeper going on. And what Unsigs really help to get at, I think, is that sure, yeah, we can put some images on someone else's servers. This is taking longer to load because it's the higher quality image. Okay, both of those are linked conveniently from the Unsigs website. Okay, but the real story is not here where we look at this image. The real story of this NFT is actually on the Cardano blockchain. And my goal is to show you today a little bit more about how this works and put some pieces together. So sure, there's an image here and it's stored somewhere. But for me, what's most interesting is that we have a bunch of information. And if you go to pool.pm and you find an unsig, you can look through the different properties down at the bottom of the screen. We're going to look more at these in just a minute. You also see this source TX ID. This is a really big deal that we're also going to get to in a moment. And then you see this asset ID up here. And this is what I'm interested in first. Let's go take a look around. I'm going to copy this. And I'm going to head over to Cardano scan. This should look familiar if you looked at the previous starter kit. And I'm just going to search for this asset. Let's see what we see. So there's a policy ID. And because I'm tinkering, what do I see there? Oh, okay. This policy ID is associated with all of the unsigs. There's over 31,000 of them, and we can see a list. We can see the dates on which they were all created. Looks like maybe we can even see how many times each one has changed hands here. That's kind of interesting. Total transactions. Okay. What else can we see? We can see the name of this particular unsig with this particular number. We can see this fingerprint. Okay, that matches this asset ID. So I was just calling it an ID. Over here, you see that's called a fingerprint. Okay, that's interesting. Looks like a unique identifier. Neat. And then we can see a little evidence of who purchased this transaction, right? And the way this worked is you would send 50 ADA to an address. It looks like this happened on June 2nd. And then you would get back 2 ADA and some unsigs. At first it was 3, and then it decreased over time to 2 and then to 1. So that shows us kind of the sending part, okay? And this is one distinction I want everybody to make today. Sending an NFT is one thing, right? And you can do that as many times. Once it exists, you can move it around. You can send it to a friend. You could sell it to somebody. You could buy from somebody else, right? But minting is a very special thing that doesn't happen over and over again, all right? And if we want to learn more about how this thing was minted, there's a tab for that right here as well. We can look at this mint transaction. And this has a specific transaction hash. And what you can see here is on that date, June 2nd, 3 tokens were minted at the same time, okay? And this is actually the 3 tokens that you'll see right here. I went in and grabbed 3 of these because I thought it was pretty cool. So there's my Unsigs, right? So those were minted together, and you can click on, right, the same policy ID, but a different fingerprint for each. But what's the most interesting is here, this metadata, okay? And this is what this starter kit is about. I want to talk about metadata and minting, and in particular, what we see in the metadata here so we can figure out what we can do with it. So this, if you've never looked at this, I'm sure this is a little bit overwhelming at first. And my goal is to just help you kind of slow down and start to think about what we see here. There's a number up here. It says 721. We'll talk more about that. There is some kind of hash right here, OE1426. And if I go back here to this policy ID, that's this hash, okay? So this is the ID. This is like a public key for minting official Unsigs. And only the person or the people who have the private key or the signing key for this policy can make more Unsigs. At the end of this video, I'm going to make some Unsigs, okay? But I'm not going to be able to mint them with this original policy ID, which has the official 31,119 Unsigs on it, okay? I can fake it, but I can fake an Unsig. I can fake the art, and I can actually use it. I mean, this is, I think, this is what Alex is encouraging us to do, is to mess around with this code and do stuff. But we can't mint real ones, right? Just like I can't send money from somebody else's address or somebody else's wallet when they hold the keys, I can't mint official Unsigs. All right, I probably hammered that point enough. Sorry. Sometimes I start repeating myself. Okay, so in here, we there it is. There's the policy ID for Unsigs. And then inside, we actually see that there's 1, 2, and then 3 distinct Unsigs. And so we're looking at JSON right now. This is in curly brackets. Let me make this a little bigger so you can see this, okay? So basically the way metadata works on Cardano is you have a key that references kind of how to organize metadata on the blockchain. I need a better way of explaining that. And I made actually there's a link here. I made a starter kit back in December, that was an introduction to metadata. So if you want to learn more about that, I recommend checking this out over here. Okay. And then also, I'll just talk about these links for a second. If you've never taken a look at the Cardano improvement proposals, I recommend it. It's just a really cool way to kind of immerse yourself in the cutting edge of conversations about how people are being stewards of this network moving forward. And so one of the ones that's in progress right now is about setting standards for NFT metadata on Cardano. And so this is that 721 label. And basically the proposal is, hey, let's use this 721 label or key, okay? And then let's use an agreed upon format for processing data. And it's actually this upon which pool.pm is built, right? Basically, the way this NFT service works on pool.pm is it's watching for transactions that have this 721 key, and then it's processing the information that is following a format like or similar to this, okay? And so that's what we see here, this key. And then inside of this object, 721, there's three more objects. Well, there's one object, sorry. There's one object with the policy ID. And then inside of those curly brackets, there's three distinct objects, one for each, sorry about that scrolling, one for each unsig. And you can see this unsig starts with curly brackets right here, and then it ends with curly brackets here. There's a comma to separate it from the next object. And then that next object starts with its own curly brackets and again ends with curly brackets and a comma, okay? So this is the basic structure of JSON. You need something before a colon, that's called a key. And then you need something after the colon, that's called a value. And that value can be another object. Here, in this case, it's an array. It has square brackets around it, right? This is a key called source key. What's inside of it? An array of stuff. Okay, more on that stuff in just a moment. There's the source transaction ID, which is a hash, a string, okay? The name of this unsig has the key title and the value of this. The index has that number. And then the number of props. This is a key, this is a value, key value, okay? This is about JSON. I recommend, again, looking at starter kit number 4 and learning a little bit about JSON, which is included in starter kit number 4 if you want to learn more about that. But this is all the information we need to uniquely create a certain unsig. It's almost the whole story. And this is where it gets interesting. Remember, I was showing you here. Taking a minute to load. When we were looking at a particular, here, let me load that up again. When we were looking at a particular unsig, and a delay like this is an example of why we want more and more distributed systems, right? For some reason, this site happens to be crashing right now, and not loading up. Anyway, okay, so we won't worry about that. But what we will look at is, where is it? The source transaction ID. You can see this. This is under the image on pool.pm, which just isn't loading right now. There's a lot of people looking at a lot of NFTs, so there's a lot of reasons for systems to crash in these exciting but early days. But this source transaction is really where the magic happens. So let's take a look at this. Keep this in mind. We're going to come back to this in a little while. But I'm going to copy that transaction ID, close this modal, and go take a look. This transaction happened on May 28th, which is the day before Unsigs officially went live. And this is where Unsig 00000, the original Unsig, was minted. Same policy ID, but a very special fingerprint. And this one has some very special metadata in it, because this metadata here actually gives you the code you need to make your own Unsigs. And this is stored on the Cardano blockchain. This is not relying on Amazon or anyone else's servers. This data is available to anybody who has a copy of the Cardano blockchain or access to any of the Explorer tools that we have. Okay. Now, what's in this metadata? Well, Unsig 0000000. And inside of that, there is an array of files. How many files? Well, each one is an object. The first object starts here. It looks like it should be called unsig.py, which is a Python file. And here's the source. This is the Python code that we're going to play with in a little while. And then there's one more file down here. This is an environment file that tells you what you need in order to play with this Python code. And so in the next part, and I'm sorry, this is off my screen because I'm doing this a little wrong, but let me see. Down a little farther. Man, I'm sorry, everybody. I need to fit this on my screen, and I'm just recording wrong. Anyway, go search for this. You know what I'm going to show you instead? You can go look at this. There's a link to Unsig quintuple 0 on Cardano Scan. You can go explore this yourself and scroll down to the metadata. And then at the bottom of the metadata, it's just getting cut off on my screen right now, and I'm choosing not to take the time to fix it. But you can go look. There is still an IPFS image, a link to an image of this black square, okay? But what's kind of cool about that black square is that obviously if the media gets a hold of a black square selling for a lot of money, that's missing the point. Because what's really encapsulated here is the code we need. Okay, so that is part one of this starter kit, and there's some links here to looking at this Unsig on Cardano Scan. I also put a link to Cardano Explorer where you can see the same exact metadata. Maybe this one will let me fit it. Ooh, look, I can almost fit the image link on the screen here. And I included both because there's this subtle thing about the way these two different blockchain explorers handle quotation marks. And so if you go deeper, or if you want easier access to these files, you might have a preference between one or another. I don't want to dwell on that for too long, but it is interesting, again, in these early days, how different tools have slightly different results when they're grabbing the data from the blockchain. All right, so we've got a link to Unsig quintuple 0 on Cardano Scan and the Explorer. I gave you a link to that CIP number 25 about setting Cardano NFT standards. There's also on the Cardano discussion forum an OG discussion about these standards. You'll actually see, if you scroll to the top of this, Alessandro started this conversation as he was thinking about minting space buds. And you can go read that discussion there. And then there's also a link to a previous starter kit that I made about metadata. All right. So far we've taken a look at some transactions and where we can find this data. Now let's go play with Python a little bit and start to generate our own Unsigs. Hey, my name is James, and this is part 2 of a Cardano starter kit. Let's jump right in. If you missed part 1, I recommend going back and taking a look. what we did is we tracked down some metadata that is used to generate unsigs, and now we're going to figure out how to use it. Now, unsigs are written in a language called Python. We can see the .py right here for the code. We can see that the media type is Python. It's optional to add this to the metadata, okay, but it's obviously really helpful and thoughtful, and that's why this is enough information for us. We can go onto the chain to this immutable ledger. We can find this code, and we can say, okay, I need to build a file called unsig.py. Its media type is a Python file, and here's the source for it. So all I'm going to do is I am going to copy this source code right here, copy, and I'm going to go into my trusty Visual Studio Code, and I'm going to make a new file just like it suggested called unsig.py, and then I'm going to paste. Now, there's one thing going on here. There are quotation marks at the start and end of every line. This is because of a useful limitation of the Cardano blockchain. When you're entering text in metadata, the longest a text string can be is 64 characters. So if you want to add any text that has more than 64 characters, there is a workaround. You just have to create an array of strings, each with that maximum length. Okay, let me switch back here for just a second. I just used that word array, right? And we're going to look more at arrays down here when we're talking about props later. But what we have here is the source object. Oh, and that's not an object. That's the key. That's the name of this. And what is the value of this key? It's this array. It starts in square brackets, which in a lot of languages, including Python, represent an array. And then inside of those square brackets is a set of stuff separated by commas. That's what an array is, a set of similar objects, okay? And so we have string, comma. Here's just an empty string with a comma to create some space in the file so it's easier to read. In order to turn this into usable Python code, we just have to get rid of all of those quotation marks and commas. There's shortcuts for this. I'm going to clean up this file offline and not waste time, but what I can do is I can find and delete all these, or a lot of code editors you can do Control-D to select all the instances of something. I can just zoom down. Let's just do it real quick. All right, get rid of those. And then I can select these quotes, here at the beginning of each line, and just zip down the line. Yep, get rid of those. And now you can already see that my syntax highlighting looks a lot better here. And actually, the tabbing looks reasonable. I'm just going to have to go backwards. I'm holding Shift and pressing Tab. Yeah, that should look pretty good. Python can be picky, so I'll double check that this works. And if we see some errors, it might be because I messed up with the tabbing. But hey, look at that. A couple moments of cleanup, and now I have a working Python file. Dope. Okay, let's go back to this metadata, because there was actually an array of files. Square brackets. The first object is this code, and this object ends here with this closing curly bracket and then a comma. And then after that is the second file. And this one needs to be called unsig.yml with this code inside. Let's go. Whoops, I clicked the wrong thing there. So make a new file. unsig.yml, paste this, same idea. Let's just get rid of those commas and quotation marks real quick. Let's get rid of the leading quotation marks and that last one. And then let's just tab this stuff back this way. Okay. What kind of file is this? This is, it says env, which stands for environment. What environment is this going to work inside of? Okay. I have the file name, and it is a conda file. Okay, well, I don't know what that is, but luckily I have the whole internet, and I can look it up. And indeed, this is what you'll see over here, okay? Now, conda is called a package manager. Let's just pause for a moment and talk about package managers, okay? So we want to know if there's enough information on chain to actually build your own unsig. And yes, there is, and it's amazing, and that's what I'm trying to show you right now. A side note, to be a good developer, you got to get good at not repeating yourself, right? As often as possible, the best developers, they're not reinventing anything, unless, of course, they want to tinker and learn something, right? Like redoing something that somebody else has done is a fabulous way to learn. But if you're trying to be productive for production, you probably don't want to spend reinventing wheels, right? So that's why package managers exist. And that's actually what Conda is. Conda is an open source package management system and environment management system. Oh, I just saw that ENV, environment. Okay, that's making sense. It's package management. Let's figure out what that means, okay? So in development, there's these concepts of design patterns and package managers. Conda is a package manager. What it allows you to do is grab work that other folks have already done so that you don't have to start from scratch. Unsigs uses two packages in particular. Of course, it uses Python because it's built in Python, and what Conda does, it allows us to say, okay, let's use this version of Python, right? 20 years from now, when who knows what will have been built on Cardano and who knows what version of Python will exist, you're still going to be able to access this data exactly like it looks today because it's immutable. That's the beauty of the blockchain, okay? And maybe Python 20 won't be backwards compatible with Python 3.8.10. I hope it will be, right? But if it's not, like this shows you, right, 1,000 years from now, archivists will just have to go and figure out, okay, Python, yeah, let's go find that out, right? I'm being a little silly naming these lengths of time, but this is what this makes possible, right? All the information is here, and it gives us a way to play with it. So in addition to Python, there are two packages that we need to use, NumPy and Pillow. These versions, okay? And these hashes here, they kind of tell Conda what to look for. All right. And so package managers exist in all well-established development ecosystems, and they just provide tools that people use again and again. All right. Now, you shouldn't trust a package manager just by, just from somebody just because they chose to make it. But luckily, there's ways to rate these things. Sometimes it can be hard to publish a package manager without first proving its security and viability. Other platforms have community rating systems, and you can see how many other developers used a certain package, and you can decide whether to trust it. You can also just go and learn about packages directly, and I put links to each of these here. So here's the dedicated website for NumPy where you can learn about it. What is it? It's the fundamental package for scientific computing. Okay, cool. Unsigs used some scientific computing, and the artist didn't write all these scripts himself. And we'll go look at which ones Alex is using, okay? There's another one called Pillow. What does Pillow do? Well, in the code, actually, we only need, see, it says from pill import image. We only need image. That's why I linked directly to this. But you can read more generally about Pillow here. Okay, here's the full documentation and the image documentation. And you can see other stuff, right? This is how development works. If you want to be good at it, you got to be good at reading docs and finding tools that do what you want them to do. And this, again, is why I think Unsigs are an interesting artistic achievement, because these tools are out there, right? It wasn't about building the tools in the first place. It was about using them to create something beautiful. Just like if you're a musician, right? Anybody can pick up a guitar or a drumstick, but can you make art out of it, right? That's what we're seeing here. Now, another concept is design patterns. And we're going to talk a little bit more about design patterns in part 3 of this starter kit. You can Google this term, design patterns. You can Google the term package managers to learn more about these. But in any well-established ecosystem, there are best practices, right? There are right ways to do things or most efficient ways to do things. And where those design patterns come from is from people trying stuff over time and establishing these kind of emergent ways of doing things. So right now on Cardano, when you hear people say that Plutus is difficult, there's a lot of reasons for that. One of them is that we haven't yet had the time to establish design patterns. Isn't that amazing? All of the work happening in Plutus right now is forging new ground. And over the next few years, design patterns are going to emerge. And it's going to make development a lot more efficient, and it's going to make a lot more room for creativity. We'll talk more about that in just a minute, but I just wanted to point that out today. When you think about what development is, it is about using what is out there, leaning on people who have built stuff already or established patterns, okay? Now, by the way, Python is, like I mentioned, an incredible way to work. This is not an affiliate link or anything. I'm just giving you a link to something that I think is awesome. No Starch Press publishes amazing ebooks and hard copies of books about Python. And just look down this list. There's so many of them. My son has worked through Python for Kids. We did it together, but there's also all sorts of other kind of specific applications of Python. Python is cool because the syntax is fairly simple as opposed to something like, say, Haskell, where the syntax is just a lot to wrap your mind around. Syntax is relatively simple, so it's good for beginners, and experienced developers love Python because it's just a really cool way to use your computer as a tool. And this is one last thing I'll say about developers, right? Developers are not afraid of screwing up. They recognize that a computer is a tool, that of course it can be misused. Of course you can break it, but crashing a computer program doesn't mean you broke a computer. It just means you're learning and you're tinkering and learning how to play the tool. And that's actually an idea that comes from this book. Alex and I were talking about it recently. This is a fabulous book for getting some insight into actually using your computer, more like a kitchen knife, right? And less like something that you have to avoid. Okay, cool. So a couple of detours there, but it's just really important. My goal in saying all of this is to encourage you to come out and play. Let's build stuff together. All right. Anyway. Now we have this file, unsig.py, ready to go. And we have this YAML file right here, which basically tells Conda what we need. Now, Conda can be difficult to set up. I've actually set it up already. I'm not going to walk through those steps. I'm going to encourage you to go look at the documentation and get it set up. If you crash, just let's if I have to revisit this, I will, but it's just beyond the scope of this starter kit, okay? So I want to show you a different way to think about this. Conda is one package manager for Python, but there's another one called PIL, P-I-L. Oh, nope, sorry. PIP. I'm thinking about Pillow, which is one of the packages. PIP. Here it is. PIP for installing packages, okay? So you might be able to get Conda to work, and it's working here, but on some devices I found that there's some hiccups in it. So I don't fully recommend it just because you might run into roadblocks. If you try to install Conda and set this up and it doesn't work, your other option is simply to use pip. All right. And so let me see here. I think I just want to say pip install, right? Yeah. Yeah, good. So check it out. I mean, basically, little squiggly lines mean you have a problem in your code, and it says import numpy could not be resolved, import pill. This is a problem with my environment right now, but I want you to see this. This code will actually work right now because I do have Conda running, and you'll see on my command line, Conda does this. It shows you basically which environment you're in. But in VS Code, I haven't rigged that up, and I want to show you something. If I say pip install numpy, never mind. It says requirement already satisfied. Anyway, man, I hope I'm not confusing you more, but I'm going to keep recording this because this is what it's really all about, is kind of wrangling things together. Basically, if for some reason you don't get Conda running, you can always pip install numpy and then pip install pillow. And you can see mine says both of those are satisfied already because I'm already running this environment. But you don't actually need Conda to get this work. You just need Python running, and then you need to use pip to install these two packages, okay? I'm also not going to cover installing Python and pip today. There's documentation for that. But if there's enough interest, I'd be happy to run like a live workshop or something if people wanted some help getting this done. But I encourage you to go tinker. Go beat your head against your desk for a little while. You might have to. It's part of learning to develop and, you know, reading errors and trying to figure out how things work, okay? Anyway, now that this is working, we can go actually create some of our own unsigs, okay? Okay, you stuck around for all of that. Now let's do the fun part. Let's actually make some unsigs. So first of all, now that my environment is set up and I have this Python file, unsig.py, this really is all I need. Okay, watch this. All I'm going to do here is I'm going to type Python 3. Actually, I don't think I need the 3 anymore on this device. Let's just try this. Yeah, that worked. Okay. This code just generated unsig quintuple 0. There it is. You run that code, you get a black box. Cool. Okay. Now, whatever. We can get really excited about that black square because now we kind of understand where it came from. It came from code that is all published on chain. But now the real fun is that we get to start building our own. I don't know. Let's rebuild this one right here. This says that it's a 5 prop, which is pretty common. All right. And let me get this asset ID again and go here and go to the minting transaction for this one and into the metadata. And which one am I trying to build? 25460. Now you can see these properties here. I could just copy these from here, but I want you to see that all of them are in the metadata as well. 25,460. All right. I can grab this data and I can just move it into that file I'm working on. Let's see. So this has, it's the index 25,460. I could call it whatever I want. I'll show you that in a minute too. It has 5 properties. And then these multipliers, remember this idea of an array, square brackets with a bunch of comma separated values. The multipliers for this one are 1, 1, 2, 2, 2. All right, so let's put those in. 1, 1, 2, 2, 2. Good. The colors, red, blue, red, green, green. I don't feel like typing those words over and over again, so let's grab them and put them here. Maybe it would have been faster just to type these, right? Because now I got to get rid of all this space. Choices. Okay. Yeah, I would have been faster typing. All right. And just get rid of that. Good enough. Good enough. Let's see what's next. Distributions. It's all CDF, which is more common than normal. If you know what I'm talking about, you're a nerd, and I love ya. And then rotations, 90, 0, 0, 0, 270. Okay. 90, 0, 0, 0, 270. Words have to go in quotes. Numbers don't need the quotation marks. Actually, shouldn't have the quotation marks, okay? So what I'm going to do here is I'm going to save this code and watch over here where this PNG image was generated, because when I run this script again, the outcome is that it's going to generate, when it's done working, another image. And that image right there should match this one right here, does it? Yeah, looks good to me. Cool, right? So think about this. This image was just, this image was just made on my computer. Okay. This image is not stored on any centralized server. All I did is I grabbed the code from the public immutable ledger and was able to build this. I think that's so cool. Okay. Now, where it gets really interesting is I can start screwing around and making my own. For example, I've always wondered what a 7 prop would look like. Or a 10 prop. Hey, I could do that now. Right? Let's just double the number of parameters in each of these, yeah? CDF all the way, let's do it. I'm tinkering, and I can do whatever I want because this code is right here, right in front of me. And if it's not pretty, nobody's ever going to know. Shh. Okay, let's see. And here, I'm going to put like a 99 on front of that to give it its own index. And then I'm just going to go for it and see what happens. 10 props. Takes a little longer, right? But eventually it's going to spit something out. Gosh, I'm so curious. What is this going to look like? Huh. Doesn't look that strange. A couple more lines on it, right? All right. And here's the thing, right? If you've wondered what different parameters do, now you can play. Let's see. What if I went back down to like, I don't know, 4 props? Right? And watch this. I just wanted to show you something. If I save that code and I run it, I get an error. Can you see the error? I left the number of props as 10, and so it actually tried to go through these arrays, okay? And it couldn't find 10 values. But if I switch that back to a 4, save it, and run it again, it works, and this looks a bit more traditional. This might be a real unsig. I'm not sure which number it would be, right? Okay, so we now have a file that we can play with and we can explore. Dimension, how many pixels? This is a 4K image, right? But if you wanted to ever print a giant unsig, right, as big as you want, you could put a much, much, much higher number on here, high enough resolution to match your printing needs. The properties go in here, and this gives us room to play. For example, what if one of the multipliers was 100? Would that be interesting? Well, I don't know. I'm not the artist. I'm just tinkering. You see, this is where you start to see the art behind this stuff. What about much smaller numbers, right? You could try all of these multipliers that are not part of the real set and see if you can find anything. Let's see. So save that, run that. 0.1, 0.1, and a couple of 0.2s as multipliers. Kind of brown. It's kind of neat. It's a no-liner. Right? So we have these options to play with it. More on that in a minute. But then down here, then you can look at the code. And I want you to see two things. Here's where we bring in our packages. We imported all of NumPy as NP. So anywhere in the code that you see np dot something, np.zeros, np.uint32, np.interp tile, etc. All of these are functions that are built into or that come with the NumPy package. And if you go to the NumPy website, you will find all of these in the documentation. I'm going to leave that for you to explore, okay? Find out what all these things do. From Pill, we only imported image, so we use a slightly different syntax. And where can I see the word image? It's just down here. So the Pill package is only used at the very end when we are generating an image from this array. It says from array NFT. And basically, one cool way to start understanding code is just to try to look for references. So for example, NFT, where else do I see that? Oh, I see that here. Do I see it anywhere else? Up here, Gen NFT, NFT, right? Oh, Gen NFT, right. Oh, Gen NFT, it's passing unsig. What was unsig? Ah, that was this object here. Oh, okay, so we have this gen NFT function that takes an NFT. What is that? The NFT that we're passing? Well, we're passing unsig in place of that here, which is this object here, right? So I'm not going to explain every line of code here. What I'm trying to do is model for you how I might start thinking about reading somebody else's code. Let's do something that looks a little more traditional again. Let's make this a 270 at the end. And run it. And this is just overwriting whatever I have at 9925460. Okay. Yeah, that's a pretty standard looking unsig, right? So in addition to playing with these properties here, I could also go down and maybe screw with the code a little bit. I don't know. I see a 0.5 here. Whenever I see a 0.5, I say to myself, well, what if I made it a 3.5? What would happen, right? Well, what would happen? I'm not afraid of breaking this thing, right? I'm just tinkering. Whoa. Zigzaggy. That's kind of interesting. It's a good thing Alex is the artist, because this is not as pretty, but it's certainly compelling. Okay. What if I made that a smaller number, like 0.1? And I print it again. That looks a little bit more familiar, a little more space. It doesn't have the balance of the real thing, but it's kind of neat. Here's another variable, 2. What if I changed that to a different number, like 5 or something? What would that do? Kind of cute. Not the real thing, right? Again, we're tinkering. Feels like 5 was pretty dramatic. Maybe 3 will be less dramatic. And notice, I'm not trying to explain, oh, no, that's less cool. That might be a neat background. See a little magic happening up here. I don't know. Right? I'm not trying to show you everything here. What I'm really trying to do is model for you what it looks like to tinker. If you want to understand this code, start learning Python today. You won't regret it, okay? And this will put you on a pathway towards building stuff. Or at least having better conversations with other people about building stuff. All right, there's other ways I could break this thing. I think I tried to change this number to a 4 earlier today. Oh, that did work. Maybe I should. Yeah, but it didn't print anything. See, okay, so right, there's some numbers I can change and they'll result still in an image, but other ones that won't, right? So it's kind of cool just to go around. You can't screw it up, right? You're just playing. All right, so I hope that this has been a helpful overview of this code. It's obviously not a comprehensive Python tutorial. Those are out there. And if you're starting to feel like, yo, this is something I want to do, learn about package managers, get Conda set up if you can. If you can't, get PIP set up and import NumPy and Pillow, and then you'll be able to run this code.